Hello, welcome to another episode on calculus. Now in this video we are going to look at how we can differentiate a function of the form ax to the power n or ax exponent n. So we have a function f at x equals ax to the power n. Now this function f at x can also be written as y. So y equals to ax to the power n. Now whenever you want to differentiate a function, we have a dependent variable and an independent variable. So in this case the y is the dependent variable and then the x is the independent variable. So to differentiate a function, we always differentiate the dependent variable with respect to the independent. So in this case we are going to differentiate y with respect to x. That is what we call dy dx. It means you are differentiating y with respect to x. Now the function of this form, we have independent variable, what is the x that we have talked about already. We have the constant a and then the exponent n here. Now to differentiate a set function, you always multiply the exponent by the constant. You multiply, okay. So that is going to give us a multiplying n, then you bring your independent variable x. Now the exponent of the x will now reduce by 1, so that is going to be n minus 1. I hope you are getting it. So the y dx becomes a times n gives you a n, then x to the power n minus 1. Good. Now let's look at a simple example that will help us to understand this concept better. So assuming we have a function f at x is equal to 2x to the power 3. Now the function, the f at x can also be written as y, then your function will come 2x to the power 3. Now to differentiate this, let me repeat the function here. Y equals to 2x to the power 3. So we are going to differentiate the dependent variable, which is y, with respect to the independent variable, which is x. So differentiating y is going to give us dy dx equals to, now once again we are going to multiply the exponent to the constant. You see, this is the constant we are talking about. So the exponent has to be multiplied with the constant. So that is going to give us 2 times 3. Then you bring your x. Now the exponent of this x will now reduce by 1, as we were doing over here. Good. Alright. So the y, the x will now be giving us, now 2 times 3 will give us 6. And then you write your x. Now 3 minus 1 gives us what? 2. So that's the derivative of such function. Let's take another question, or a simple one. So y equals to, let me use different color. So you have y equals to, let's say, negative 3 x to the power negative 4. Alright, so this is of the form, your y is here, the a is negative 3, the n is negative 4. So it's the same process. So we are differentiating y with respect to x. That will give us dy dx. Now, how do you differentiate the function negative 3x to the power negative 4? Now, this negative 4 here, as exponent, will come and multiply the constant 3. Okay, they will multiply. So, negative 3 multiply negative 4. Now, you bring your x, write your x nicely. Then, the negative 4 will now reduce by 1, so that is minus 1. Right, so the x is equal to, now negative 3 times negative 4 gives us positive 12. Then you bring your x, then negative 4 minus 1 gives you negative 5. So that is the derivative of this function. Now let's take one more on this slide. Let's take one more. Good. So we have another one. Let's say y equals to maybe 4x to the power negative 3. Okay, 4x to the power negative 3. So differentiating y with respect to x, dy dx is equal to, now let's multiply negative 3 by, so negative 3, what is the exponent? We are multiplying it by the constant here. So negative 3 times 4 gives us negative 12. Now x, okay, now negative 3 minus 1 dy dx is equal to negative 12 x to the power negative 4. That is negative 3 minus 1 gives us negative 4. So that is the derivative of this function y equal to 4x to the power negative 3. Good. Let's see more examples in our next video. Please don't forget to subscribe, comment, and you share. Thank you very much.